Problem 3. S bar 5 plus 2 into S bar 4 plus 3s cube plus 6x s square plus 2s plus 1. So here all the coefficients are present. Which are the coefficients? 1, 2, 3, 6, 2, 1. These are the coefficients. You need to construct a root array using all these coefficients. So starting from S bar 5, this is the highest order and the least order is S bar 0. So starting from S bar 5 to S bar 0, construct a root array. First A1, A2, A3 is 3, A4 is 6, A5 is 2, A6 is 1. So by making use of the coefficient of characteristic equation, fill the first and second rows. Next we need to find out the elements which are present in the S bar 3 row. So how we are going to calculate it? 2 into 3, that is 6, minus 6 into 1, 6 divided by 2. So 6 minus 6 divided by 2 is 0 by 2, that is equal to 0. That you need to write in the place of S cube row. So that is 0. And the second element of the third row can be calculated as 2 into 2, that is 4, minus 1 into 1, 1, 4 minus 1 divided by 2. So 4 minus 1 by 2 is 3 by 2, that is equal to 1.5. That you can write it in the second column of the third row, that is 1.5. So we already know that in the Routh-Hurwitz criteria, the first element of any row should not be 0. That is the first difficulty we have already studied. So in the third row, the first element is 0, but the first element should not be 0 and the remaining element must be non-zero. So this is, we can consider this as a difficulty 1. So here the first element is 0. So what you can do? If the first element of any row is 0, then we can replace that 0 by a positive value called epsilon. So instead of 0, we can replace epsilon in third row. So by making use of this small positive value epsilon, we can calculate the next element of the root array, that is S square row. So the x square first element is epsilon into 6 minus 2 into 1.5 divided by epsilon. So that is equal to 6 epsilon minus 1.5 into 2 is 3 divided by epsilon. That is the first element of S square row. And the second element can be obtained by multiplying epsilon into 1 minus 0. That is 2 into 0 is 0. Epsilon minus 0 is epsilon only divided by epsilon. So epsilon by epsilon will be equal to what? 1. So we can write the second element as 1. Next, we got the values of S squared row. Next, find out the values of S bar 1th row. So multiply 6 epsilon minus 3 divided by epsilon into 1.5 minus 1 into epsilon is epsilon divided by 6 epsilon minus 3 divided by epsilon. So like this we'll get, this is a complex value. So instead of taking this larger parameter, we can simplify this first by taking LCM and all. So we'll get 9 epsilon minus 4.5 minus epsilon square divided by 6 epsilon minus 3. So we can write this expression in place of S bar 1 row. That is the first element of 5th row. So next we need to find out the second element of S bar 1th row. So how we are going to find out? 6 epsilon minus 3 divided by epsilon into 0 minus 0 into epsilon. 0 minus 0 is 0 itself divided by 6 epsilon minus 3 divided by epsilon. So 0 divided by anything is 0. So we can write 0 directly. After that, the last element of the root array can be obtained from this 9 epsilon minus 4.5 minus epsilon square divided by 6 epsilon minus 3 into 1 minus 0 divided by the same term. So the same term will get cancelled. The remaining value is 1. So this completes the root array. So we have completed the construction of root array, but in order to find out the stability of the system, we don't know the signs of the elements which are present in the first column of the root array, because here we don't know the exact value of the epsilon. After substituting the epsilon value, what you'll get, it may be positive or negative. We don't know that. We need to find out whether this value is positive or not, and this value is positive or not. But the epsilon value that we have taken is a small positive value, so this number has positive sign, but we don't know the signs of these two. So the remaining are positive values. We need to find out the signs of these two parameters. To find out the signs of these, as per the difficulty number 1, we need to apply the limit that epsilon tends to 0 to these two terms. So first let us consider the first element, 6 epsilon minus 3 divided by epsilon. So if you apply the limit to this parameter, if you substitute epsilon equal to 0 in the original expression itself, you will be getting 0 divided by minus 3 divided by 0, or you can also write this expression as 6 minus 3 divided by epsilon. Substitute epsilon equal to 0 here. 6 minus 3 divided by 0 is infinity. 6 minus infinity is minus infinity. So you are getting negative sign for this. So this is minus infinity. You should consider, even if it is a infinity value, you should consider whether it is positive infinity or negative infinity. So for the 6 epsilon minus 3 divided by epsilon, you can write the value as minus infinity. So the sign for the square root value, that is first column element, is minus infinity. Next we can find out the sign of the next parameter. Apply limit to this. So if you apply the limit to this, epsilon tends to 0. Substitute epsilon equal to 0 in this equation. So 9 into 0 is 0. The remaining value is minus 4.5 minus 0. So in the numerator you got minus 4.5 divided by 6 into 0 is 0. The remaining value is minus 3. So 4.5 divided by 3, it gives 1.5. Negative negative get cancelled. So this is 1.5. The value for S bar 1 through first element is 1.5. That is positive value. And you can see here you got the signs for all the elements of the first row of the root array. So this is the first row of the root array. This is positive, this is positive, this is positive. First three elements are positive. There is no change. Positive to positive, positive to positive. But the fourth element is negative. So this is positive to negative. There is one sign change. And also here this is negative to positive you are getting. So there is another sign change. And next is positive to positive. So there is no sign change here. So we can consider only two sign changes. So since there are two sign changes in the first column of the root array, we can say that the system is unstable. And also the total number of roots we can obtain from the given characteristic equation are 5. So out of 5 roots, 2 roots are present in the right half of the S-plane and the remaining 3 roots are present in the left half of the S-plane.